Good afternoon, everybody. Welcome to the technical training webinar on the use of biodegradable materials in farming. The webinar is organized by the Association Chimica Verde. I represent this association and I'm the director of the association. Just a couple of words on the association itself. Meanwhile, I try and share my screen. Association Chimica Verde Bionet was developed in 2006 in order to promote the research and application of vegetable raw materials and materials of biologic origin to replace products and materials that are not renewable and often dangerous and hazardous to mankind and the environment. Green chemistry, like chemistry in general, has various application sectors, including farming. I'm going to talk about farming today. Agriculture has a very special role in green chemistry because it's the main supplier, its main source of renewable materials on which green chemistry relies, and also molecules used in green chemistry. On the other hand, industrial farming, the way we've known it, is often a major consumer of non-renewable resources, fertilizers, pesticides, water, energy, and the soil in terms of degradation of the organic matter, but oftentimes also in terms of destruction of the ecosystems that live in the subsoil. And farming practices also use a lot of plastics from fabrics, mulching fabrics, containers, and also covering materials and nets. The solutions proposed by Chimica Verde green chemistry relies on biodegradable materials that are low toxicity materials. These are attributes which characterize the products that we usually propose with green chemistry. Not always a biodegradability, but products that are also meant deliberately not to be biodegradable. Now, we have presented and analyzed many of these products in a survey carried out with the Rurale Nazionale in 2019, specifically on horticulture and food growing in Italy. In this survey on horticulture as well as food growing using the resources that I was mentioning before. Now, in this survey, we looked at the possibility of using a series of products that are already available in farming. Here you see four major sectors. The first one is fertilizers. In this case, green chemistry would like usually proposes composting, digestate, and biochar, and also residues following composting and energy residues. And then we have a big group of alternative products for pesticides, from biopesticides, biofumigating agents, and also antagonist insects. And then the bioenergy sector, they can be produced directly on the farm from biogas, biomethane, and also cellulose, biomass, and residues of pruning on the farm. In the sector we are particularly interested in is bioplastics, biodegradable bioplastics. Let me conclude my presentation because we really have time available and we've got many there's a lot to tell you. Well, let me close with this hemp cultivation. It's a fruit hemp cultivation, though you might be surprised here in this world. It's quite common, it's quite popular in all Italy. This is really a very good one. It's an ideal one. This is a high yield crop where biodegradable textiles were used to color white and black to avoid overheating in the summer. Underneath these textiles, we have drip lines for the drip irrigation. The plants were nourished with microorganisms and molasses, basically. And finally, we have this apparent, um, apparently weed-looking plant that is actually beans. The combination of beans and hemp may be quite good in order to increase the resistance plants to pathogens. You know that as legumes, beans are nitrogen fixators. I will stop here because also the biodegradable textile mulches will be the topic of subsequent presentations. And then I give the floor to the Director of Leonardo da Vinci. He will describe plastics in Italian horticulture. Good afternoon. Let me share my screen. Good afternoon. Thank you very much for giving me this opportunity. I'm going to cover the topic of plastics in Italian horticulture. It's certainly a very broad topic. I'm going to look at it from our perspective. I'm going to look at it from the point of view of the Unione Nazionale Ortofrutta, which actually gathers a lot of data. Actually, plastic materials are increasingly widespread in agriculture. We have three main applications covering systems, systems for covering the soil, and also plastic polymers, which create a lot of difference. Here you can see a summary of data from the literature, and you see that 45% of plastic films is used for covering greenhouses, 32% for mulching, to talk about horticulture and um, fruit and vegetables, and also in forages, we have quite a good use of plastics. The demand for plastic materials and films in Europe for farming has been on the increase, more than 510,000 tons a year. Italy and Spain are the countries, are the countries using these materials, accounting for 40% of the European demand. Well, this is not by chance. Here you see that they are countries where a lot of horticulture is performed using a lot of plastics. Here you see the areas for fruit and vegetable growing in the two countries, and here you see the aggregate surface. Concerning the use of plastic films in Italy, the regions mostly using vegetables are Puglia, Emilia-Romagna, and Campania, as well as Sicily. In terms of table grapes, plastics are used especially for covering purposes, but we might talk about plastic non-film materials for the orchards. Plastics indeed have a very strong impact, causing also problems. Here we made some calculations. We considered 280 kilograms per hectare for mulching. We multiplied this by 101,000 hectares of crops, possibly mulched. Then we'll see why, and we end up having 28,000 tons of mulch used and 18,000 for greenhouse covering. So basically, for these two types of use, end up having 50,000 tons. Then you have to add all the plastics for the factories. Any plastics therefore represent a problem from the environmental and it is increasingly difficult to dispose of these plastic materials in the correct way, and it's difficult to find companies that recover plastics. Also, the Chinese market has stopped. Now, let's talk about fruit and vegetable growing. There are reimbursements for plastic materials or similar materials, either films or other products, to the extent that they contribute to a improvement of the production and also improvement in the environmental sector because of the reduction in chemical substances used. Well, this is a special focus on mulching. Our support policy is for conventional and biodegradable mulching films. Here's the photo in red because it is actually in high decrease, but now all materials are biodegradable. So one first point we should make is that the unit cost, which is recognized to conventional plastics, is around 2.20 euros. One unit cost for biodegradable material is 6.30. And then if we compare the costs to the surface unit, standard plastics are about 700 euros vis-a-vis 500 for the biodegradable plastics. In the calculation system, we also have to consider the workforce savings and what is actually saved to remove the biodegradable material. And this is one of the ways we could act. I won't tell you what mulching is and what it is used for. Here is a summary of the main crops that can be mulched. In the first column, you see the surface, the area, and this is the mulched area, 101,000 hectares, I was mentioning before. This was detected through a questionnaire. We've asked our organizations to indicate the mulching level of these crops, as you can see indicated. So what was the result? 90% of these crops are subjected to conventional mulching. Only 10% use biodegradable plastic films. The pros and cons of using mulching is summarized here. Certainly, there is a reduction in the use of food killers and the use of water. We have, so to say, clean fruits. On the other hand, there are problems for disposing of non-degradable films. We're reading the questionnaires. You see a series of pros and cons to the use of biodegradable plastic. Dr. Falcone, you only have 2 minutes left. Yes, almost done. So there is an advantage in terms of reducing costs and increasing sustainability. recyclability. Among the disadvantages, you have imperfect optimization of the high purchasing costs. Here we have 39 interviews that were conducted for an area of more than 5,000 hectares. These are the cultivations. What comes out from this survey is that the motivations are stopping producers from using biodegradable textiles. First of all, lack of optimization, and also too high costs of purchasing these materials. Of course, in order to increase the use of these materials, we should improve their duration, we should optimize their duration and reduce their cost, as well as support policies so that the non-biodegradable polymers are increasingly replaced with biodegradable ones. Thank you very much, Dr. Falcone. Well, of course, we don't have any reactions from the audience. It is as if we had a wall in front of us, but never mind, we'll carry on. Now, the first experience in the use of microplastics is showed in video paper with Mario Torelli talking about biodegradable mulching in the case of watermelon plants. I'm sorry, I'm told that uh, you can't hear the sound of this video. Never mind, we hope that we're going to fix the sound problem. Meanwhile, I will hand over to the next speaker, Francesco Degli Innocenti. He's a part of a European UniCT 600/SC27. It's the subcommittee dealing with environmental aspects relating to plastic materials. Good afternoon. Good afternoon. I will very briefly talk about what biodegradable plastics are. Now, to do so, I have to go into some chemistry. I hope I will be simple enough. What's the difference between biodegradable and traditional conventional plastics? Conventional ones are polyolefins. They are carbon atom chains, one after the other. As you can see in this diagram, you have polyethylene and polypropylene here. This structure structure is harder for microorganisms to attack. It's very resistant to biodegradation. If you look at the structure of biodegradable polymers, you see that the majority of them are polyesters. They are characterized by bonds shown by these red circles. These are esters, and contrary to those that we saw before, these bonds may undergo hydrolysis. Water, in other words, interacts with these bonds and breaks them. Why? Why does this happen? In nature as well, there are enzymes which are capable of accelerating this reaction. These enzymes in nature break bonds such as those that we find in triglycerides. Triglycerides have ester bonds. These are bonds with which enzymes have a certain experience. They're not unknown to nature. How does biodegradation take place? Here you see a bacterial cell. Polymers cannot enter the cell directly because they are macromolecules and they don't go through the membrane. They can't do so. The bacterial cell releases extracellular enzymes shown by these Pac-Man diagrams. They attack the ester bonds, then oligomers and monomers are formed. They enter the membrane. They enter the cell. They participate in cellular biochemistry. They turn into biomass and are then broken down to produce carbon dioxide, which is the final point of degradation. So from a polymer, you end up having CO2. Well, one can measure the end point of degradation, that is CO2, in a lab using systems like this one, flasks, reactors, within which we place soil samples. It might be compost as well. Soil to which we add the polymer, the plastic that we're interested in investigating. Then what we do is measure the emitted CO2. This reaction we actually evaluate or assess biodegradability. Biodegradability is assessed based on cellulose behavior. Cellulose is the reference material which is universally used in biodegradation. Cellulose is a natural polymer. Let's see how cellulose in various testing conditions emits CO2. The biodegradable material must have a behavior which is similar to that of cellulose. These are the basic requirements and standards of biodegradability. More specifically, when we talk about the plastics and polymers used in agriculture, for mulching films, there is a European standard which is called biodegradable films for mulching for use in farming and horticulture requirements and testing methods. So what are these requirements? The first requirement is the inherent biodegradability, which is to be assessed via biodegradation tests in the soil. ISO 17556 is the test I showed you before with a big flask and the soil inside it. But to avoid any doubts on negative effects, this standard also requires that you carry out ecotoxicology tests. Ecotoxicology tests are carried out on the soil where quite large amounts of plastics were left. What about the toxicology tests that are carried out? Well, Various terrestrial taxa are examined according to increasingly lower levels. You have higher plants first. The process is primary production. Exposure pathway is the interstitial water through the root absorption. There's a specific test, the acute toxicity plant growth test. Second level, invertebrates, worms. In this case, the breaking down of the organic substance is the process with the formation of the structure. Well, there are various absorption pathways, not just interstitial soil or water, but also ingestion of materials. There are two tests. One is an acute toxicity, and another one is a chronic toxicity test with earthworms. Then bacteria, microorganisms, with a test for inhibition of vitrification. This is also a standard test. The mulching films, when they are degradable, leave all inorganic materials behind. If there are metals, they stay. So the standard defines maximum concentrations of various elements which have been deducted from the criteria used. Well, you only have one bit left used for the eco-label process divided by 2 to take into account the fact that we don't release hazardous substances, heavy metals, or other worrisome substances. On the field, the environmental conditions can be of various types, depending on the season, climate, etc. So rainfall, temperature, and other elements may interact with the degradation process. The standard recommends that tests are carried out on limited areas which are representative of the expected use so as to validate the type of selected film. We don't want degradation to be too slow or too fast. This is my last slide. Please note that one can follow degradation also visually. For EN 1733 films, the breakdown is actually a true biodegradation is accompanied by the disappearance of CO2. Here, for example, it does not disappear, it does not produce CO2. The mulching film behaves similarly to leaves and paper. That's important. Thank you very much, Dr. Denina Cheng, for being available to you. It's a bit difficult, but we have to make sure that everyone can speak. We have talked about biodegradable textiles, we talked about biodegradation, but what does the CAP do for biodegradable materials and textiles? Carlo will explain this to us. He is from the Agricultural Council of the region. You can see the farmers finally decided to go for an easier solution. Let me immediately talk about the future of CAP. I'm not here to describe what's about to happen because I don't know, and of course it's still being discussed. There are 2 programs, the Green New Deal and the program which set the guidelines of the new CAP in the environmental arena. You can see the eco schemes
20 to 30% of the first CAP pillar. So it would be a large amount of money, 3.5 billion euros for Italy. So it would be over 700 million euros annually to be used in the framework of these eco schemes. And then we don't know much about the environmental policies. We really don't know what's going to happen there. Biodegradable materials could be included in these eco schemes, but probably 20%, 25% of the EU should be covered with organic farming. For the time being, in Italy, we are about 18% as a region. We're more or less 18%. We're doing quite well, but there's a lot of room for improvement. We undertaken some of these initiatives, either directly or implementing biodegradable agriculture. You have less than 1 minute, and then your time is up. Additionally, for horticulture, we should also reach 25% of resources allocated to environmental initiatives. We're now spending 13% at a national level and much less at a regional level. So there's some room for maneuver there. Moreover, at least 5% of CM operation programs should be devoted to research and experimentation. Of course, biodegradability should be a priority there. Let me come to my conclusions now. We can see many opportunities offered by the CM in the future, not only in terms of mulching fabrics, but also for other products such as meshes and different kinds of support. In order for these products to be further developed, ideally they should be exclusively funded without having to compete with other plastic materials. I hope I stay within the time slot. Thank you very much for listening. Thank you very much. I totally agree with your conclusions. So the plastic should no longer be funded, not even for mulching fabrics. We have another video now by Dario Hassani, who will talk about mulching in organic farming. I'm a farmer from Imola, not from Bologna. I've been into farming for the last 22 years. The crops have changed over the years. I leagues that local markets. And this is quite easily done using mulching. I'm quite against mulching plastics. I've never used them. I always try to make crops manually. But this is quite interesting. With two interventions, we've been able to keep it clean. I didn't have to change anything. The mulching machine was the same as conventional mulching. Optimize water use as possible, using less water, soil stays fresh, better protected, and that's very good for crops. So we didn't even have to fertilize the crops. We tested this system on watermelon and just to see what happened. Results quite good. Good about plants behaving in a different way, so it's probably going to last longer. In melon plants, I've seen a good reaction, much better than plastic mulches. So the melon plants don't get burned. If I were to use the system in the future, I would feel very happy because having to dispose of plastic fabrics is quite complicated, it's quite expensive and complicated, and eradication too that I abandoned many years ago. This is a very optimum system. Thank you. So, biodegradable mulches is quite interesting for organic farming. We'll now get the floor to Alessandro Pulca from the BioAgri Shared Certification System. Floor. I work in certification, voluntary certification of products and organic certification. I've been involved with this for many years, since 1993. I'm trying to share my screen here to share the voluntary certification system that we developed in cooperation with the Italian Association for Organic Farming, IAB, and the first ones who actually volunteered to implement the certification. We observed that we lack rules about organic farming. The existing regulations have been in place for many years, let's say since 1981. So we have rules that cover the entire production process with definitions of products that can be fertilized and protected. We have regulations on the use of chemicals in agriculture, and especially in organic farming and food additives as well. New regulations are going to be implemented in 2022 with the aim of selecting admitted substances, approved substances for processing plants. So, as you can understand, it's a very ambitious goal, quite challenging as well. But we never considered mulching materials. Mulching as a technique is approved and accepted. Of course, we would encourage a virtuous attitude, but as shown in the previous video, farmers are free to choose either renewable or biodegradable materials, or they may even decide to go for conventional plastics according to the best practices envisaged for conventional farming as well. Of course, they will compliance with existing obligations and, of course, compliance with best practices. IAB is one of the leading organic associations established in the mid-80s together with the Biodynamic Association. For a number of years at the onset of organic farming, we provided certification of organic farmers. I started as a certification expert when I joined IAB. currently we are leading representatives and promoters of organic farming. So we've also played an institutional role over the years because we were originally established as promoters and guardians of organic farming at the national level in this country. So this is, we have standards and a brand identifies with organic farming. So besides fertilizers, pest control, we have another extremely important sector having a major impact on the environment, which, in our opinion, requires our commitment when it comes to regulations. So, being agriculture is the supervising body chosen by IAB to perform controls and supervision leading to certification. We are leading organizations in this area. We cover 12,000 farms. Totally, we certify 14,000 farms in different sectors of activity. And since 2017, food chain ID, both leader in genetics testing and non-GMO certification in the agri-food sector. Of course, these materials can be proposed in this area. Certification necessary. You can see different certification area. Of course, interest goes to organic farming. And then we can, of course, mention sustainability in agriculture, integrated pest control. For instance, we have a national brand for that and different certification systems in the agri-food chain, starting from GMO to sustainability and sustainable farming, CO2 energy efficiency, all areas where mulching and biodegradable materials can play an important role. We have different voluntary certification bodies. We have IAP Research. In Italy, we have other internationally recognized organizations providing voluntary certification, providing helping and supporting farmers to identify their methods and better identify methods that are best suited for farming. The obligation to certify all farmers, but no provision has been established so far in this area. Our goal, therefore, is guaranteeing that products meet these requirements, or at least are oriented in this direction, as no specific regulations exist on this matter. So they have to comply with many requirements established by the law, such as sustainability as well. So all criteria that make them particularly virtuous compared to conventional systems. Here we have multi materials that we can certify compliant with biodegradability requirements with very high content of renewable materials. So we can present our ideas about the best suited materials for this purpose. We have less than a minute left for you. I don't need much more time. Let me just come to my conclusions and briefly show the maximum incidence of renewable bio-based components in the material used for fabric, using natural renewable sources that are low GMO based on the principles of segregation and mass balance for large volumes. Total biodegradability 90% in 24 months according to international standards, as mentioned by the previous speaker. Different requirements are mentioned when it comes to composition. Certain substances being banned in the non-biodegradable fraction, the non-renewable section. In fact, we can of course reach total renewability. So percentage of non-renewable materials accepted, which has high biodegradability properties. A very small percentage, up to 5% of non-biodegradable materials with requirements and materials being selected in order to avoid more environmentally unfriendly ones. Toxicity tests are to be performed. So toxicity tests, acute and chronic toxicity of invertebrates, microorganisms in the soil. Feature of the system is that it's not only based, as the case is for other organizations in Europe, so we don't need to provide documentation. As a matter of fact, your time is up. So I'm sorry, I have to interrupt you. Your time is up. Your time is totally up. We still have a video, and he keeps talking. So that's thank you so much. Apologize for sitting on my time limit. So finally, an organic association has come to the fore and explained their stance on the matter. I'm now going to show you the video that you could see at the beginning. Azienda agricola Torelli on biomulching of watermelons. We've been asked to test this biodegradable products with excellent results. We didn't have to change any machines that we used, this mulching machinery that we used. And I think that's extremely important. We can keep the same speed as with conventional plastic. You can see that the dripping tube gets very hot, so we haven't seen any damage on this section of the fabric. Can be easily applied. See, we have 80 to 90% more flowers, and the fruit can be harvested in the end very easily. We have a considerable difference in terms of quantity. We can have the better results than expected. Material is very good for pest control as well. It doesn't degrade along the edges. It keeps its elasticity, and therefore pests respond in the same way as with regular plastic. For final harvesting, there's no problem. After removing the tubes, you can just water the area, and the fabric stays there. And this is very good in disposal terms as well. So we collect everything. They usually come and collect it, and we have to pay for it. We keep it there until next year, and then we'll see how to dispose of the material. But we need to pick it up. This is additional labor that we need. But it lasts until the end of the product, because the issue with biodegradable materials has always been related to that, you can go till the end of the crop season. So after 4 months, you're done. I think it's a very good product.
Well, we only have a few minutes. We have 100 people watching, viewers, so great attendance. I'd like to thank our numerous partners and above all the Association of Agronomists and Forest Agronomists in the Itabia region who organized this webinar. And then we also have the support of the National Association of Association of Agriculture Support of Federal and another technical partner, Itabia, and the Accademia dei Giorgofili, quite a respectful partner. There are training credits with this webinar for agricultural experts and agricultural technicians as well as economists. I think we don't really have a lot of time for questions, but please, if you have any questions, we're here to answer. Please be short. Are there any questions? Meanwhile, I would like to invite the moderator of the next session, Dr. Luciano Trentini, to join the good afternoon, everybody. You know, we get the questions with a delay of 30, 40 seconds, so we have to wait a little bit. There's a question here. Has anyone calculated the carbon footprint in relation to the use of biodegradable plastics? The use of biodegradable plastic pouches, to what extent does this affect the carbon footprint? I think it's a question to you, Dr. Delina. Yes, numerous studies have been carried out using mulching textiles. You can actually assessment on the life cycle of the product to biodegradable textiles. Our studies showing that their use is advantageous for the environment, especially as far as greenhouse gases are concerned. Thank you, Mr. Chairman. Just a short answer. The floor to Dr. Trentini. Good evening, everybody. Can someone tell me whether you can hear me? Yes? Say that we can start this session. I believe that all the comments that I prepared for my introduction have been mentioned already, especially in relation to the use of these materials. Above all of these materials yield major results from the agronomy standpoint, but also and above all the environmental standpoint. Now, these products have huge potentials here in Italy. We have specific features in Italy. We have quite a well-developed horticulture. It's a cutting-edge horticulture. This allows us to be forefront. This also shows the indicators of protected geographical origin. And all this for the benefit of our consumers that are drivers. 100,000 launched if you translate it into plastics that people used to have, we do not disperse this in the environment. The generates a lot of important insights given the use of mulch and the standards and issued so far. In the future, all this will continue to reveal with additional opportunities to the farmers. I would say that after the theoretical part, in this session, we will be more practical. I'd like to immediately give the floor to Pierpaolo Pazzotti from Astra Innovazione. Pierpaolo is a technician, a very well experienced technician from the horticulture point of view. We've worked together for a number of years, also on biodegradable plastics. Talk about the experience of his experimental company Astra, where he has developed some of the techniques. Thank you. I will be very short. I've not prepared any slides. You will only see myself speaking. The two videos, the one of Mr. and the one of La Montanara, are two farms where we have carried out the tests under the technical coordination task. A lot was said in the videos already. I will only give you some information. My name is Pazzotti, as Luciano said, and I'm responsible for horticulture. We are based in Emilia-Romagna. We have the administrative and technology headquarters in the province of Ravenna, while the two experimental farms are the unit of Mario Neri in Imola and Cinque in the province of Forlì-Cesena. We also have a testing unit and a lab which is specialized in sensory analysis with great quality of production. I'll be very brief. We started dealing with biodegradable thanks to the cooperation that we have with other partners. A lot of especially in farming have evolved progressively and the activities that we carried out to focus on high intensity areas for the crops we have considered. And we have considered the whole of the region, Ferrara, and also Bologna, Reggio Emilia, and Modena. Crops that we have assessed with biodegradable textiles were many, from industrial tomatoes, tomatoes, courgettes, melon, watermelon, and leek. The protocols that we implemented over the years made it possible to make quite a comprehensive assessment of submitted to us. We made mechanical assessments, resistance to traction, resistance to the weather, the degradability of residues. Plants were not used in the timing for degradation, whether coverage was achieved for the whole vegetation cycle of the crops, and the effective control of the weeds. Last but not least, the production effects. We also assessed whether there was an impact on the production results, on the yields of the crops. Very briefly, as I mentioned before, over the years, the textiles have considerably improved and evolved. The thickness range has increased, the colours have increased too. The colour is linked to a different absorption of sunlight, and therefore different temperatures at the soil level, with effects that can have a role in the physiology of the plant. Over the years, we have also established good relations with the farmers, with excellent farmers that gave us indications and insights on the practical effects these biodegradable textiles can have on the crops. The indications we got were quite interesting. I won't talk about production data. I've summarized a little bit what we have seen over the years. We saw very good evolution of the elasticity of the textiles. Even with 12 microns, the installation of the textiles was very good. We were able to use non-adapted mulches as well, saving time and money for the farmers. We were able to obtain very good results also when the soil had quite a large coarse particle size that might have torn resistance to mechanical stress, and the weather was very good. There were years with violent storms and hail, but the textiles did not cause any particular problems to the farmers. Thanks to the available range of films, which is quite large, we can extend, can adapt the materials to the cycle of the crops, controlling weeds in an optimal way, even in cycles of 90, 100 days. Films of two colors controlling temperature at soil level made it possible to preserve the good physiology of the plant. As Mr. Torelli said before, in some very hot years, temperature control at the collar level allowed for optimal plant development with more flowers and great production at the end of the cycle. In some cases, this was similar or superior to the conventional textiles. Using biodegradable textiles, we did not see any burns of the fruits. For example, watermelon and melon or bulb crops such as onions. The bulbs were indeed very good, of very good quality without any burns. The correct choice of the mulching film in high density crops made it possible, using only manual machines, even if we had holes very close to each other, made it possible to optimally control the weeds until the end of the vegetation cycle of the plants. When I speak of high density crops, I refer to tomato crops, industrial tomato crops and leeks. This has allowed the farmers to reduce costs. Savings were made on the disposing of plastics. There was no additional cost for this. The residues at the end of the cycle were degraded easily through the soil and caused no other problem to subsequent crops. It is important to stick to the standards storing and using these products. The companies attach these standards to their products, and this guarantees an optimal use of fuels with an optimal result. This is all, and if you have any questions, I'm ready to answer. Thank you very much, Pier Paolo. Your experience is a multi-year experience, which has led to very important results. I also work on the field, and oftentimes when changes are proposed to the farmers, they're always reluctant because their concept is, just this has been for a long time, why should I introduce a different technology? They have some initial doubts and perplexities. For example, the risk of not being able to place the field on site in the any experiences to the contrary. Well, actually, mulching of crops that conventionally could not be mulched became possible thanks to these fields seen mulched audience. In the coming days, we will start with garlic, mulching garlic, you know, and the crops, those that never heard about this. I'd like to have the video of the mulched crops. Dario Magnani, farmer for a couple of years, has use killers or pesticides of any type. We've used the mulching instead. Biodegradable because they are usually high area. I have to repeat the same. I'm interested in preserving a healthy environment with no plastics and contaminants. Our customers abroad, their product is pharmaceutical and a zero residue product. So we control weeds mechanically, and the results are extraordinary. They pay off. Biodegradable textiles because the weeds away 30 centimeters away. The use of biodegradable is a win solution also for customers. It is an added value that they also use when presenting the end product in pharmaceutical product. This is why we abandon plastic textiles and films opted for biodegradable textiles. Well, I a new scenario you and the world aims at high income jobs because the costs increase. We've seen experiences from the north of Italy, seen some experiences from the south introduced biodegradable the third council economic and agriculture from final on side. Actually, he's going to do helping us to put all the elements of this puzzle together.
Thank you very much, Mr. Trentini, for describing my background so well. I feel proud. I work at a research center, and therefore my experience that I will present to you shortly is a result of many years working in horticulture. Can I share my screen, please? The region of Campania, when it comes to biodegradable mulching, we started working back in 2008 at least in cooperation with government using regional funds. Therefore, we had an opportunity to follow the technological development of biodegradable textiles over the years. Our experience with the new materials. So we try to identify the best thickness, resistance, in and color differences. We didn't work a lot on that. We only worked on green textiles. We analyzed weed or killing results. Some weeds cannot very well controlled by the textiles, such as the scissors planters. It was biodegradable notice in extremely attacked soils. It can be quite problematic cleaning them up. Certain textiles can give better results than reducing the impact of temperature under plastic textiles. Then we tried to understand whether the results could at least be compatible with polyethylene. And Mr. Moore, unfortunately, we can't see your presentation. Could you please share your screen? I tried to do so, but unfortunately, okay, keep going. If it doesn't work, just forget about it. I'm really sorry. My presentation was very, very nice. Pictures. Can you see anything? No, unfortunately not. Why don't you try full screen? Doesn't work. Just keep going. Sorry about that. I'm really sorry. I've been working on this presentation for a long time. So I keep trying while talking. So the species that we worked on are both vertical crops such as aubergines or Salvazzano tomatoes, and the crops such as lettuce, melons, watermelons, and strawberries as a fruit species. That was quite interesting, in fact. Then we also worked on industrial tomato crops. I keep trying to share my screen, but it doesn't seem to work. Doesn't work. Not working. Well, I can't share my screen. It doesn't work. I'm not allowed to share properly. I can see the icon. Click on it, but it doesn't work. Okay, fine, fine. Thank you. So I'll keep going a little bit quicker, and I'll focus on three cases. One is melon that we worked on the field and in a greenhouse. We used mulching, either total mulching or in stripes. With this crop, we've been able to see that the performance of the material is good, but both for melons and watermelons, mulching results are very much on time dependent. And of course, there's competition with weeds. Let me just to show some of the results that we collected, just to show that, well, we have two cultures, Regata and Solomon. We've seen no differences. This were carried out in 2015, but there's something really interesting that we always observe in the visual company with the lens. It's a very interesting some organoleptic parameters. So the Briggs value increasing by 1 or 2 points. And when we looked at other nutraceuticals, polyphenols, flavonoids, with the antioxidant properties, we can see the difference between cultivars and different periods. The results being better with biodegradable materials. We carried out in-house tests where fruits rested on the fabric caused rapid degradation, with residues being stuck to the peel that could hardly be removed. But that was only observed at the greenhouse due to the irrigation practices. As far as the strawberry is concerned, I think this is the group that most benefits from biodegradable mulching. We've been working on strawberries for many years, especially in 2015 we worked with a strawberry farm. It's a cooperative. At the center we can see in a strawberry field in the area of Caserta. We tested different cultivars, Sabrina and Fortuna, gave equivalent results. And, two fabrics, polyethylene and biodegradable materials. You can see final results at the end of the cycle. You just remove the material and then it gets just a couple of pictures. It takes a long time, it's very time plastic. It's very expensive as well. Residues you have to be behind it. They're not easily disposed of. From this viewpoint, very good examples. This was 20 micron. We're now testing 18 micron. They lasted for 9 months. That's a long time, and no, the mulching effect was not damaged or reduced. As far as strawberries are concerned, again, variations were observed in terms of nutraceuticals. So there are two farms represented here in blue. You can see biodegradable materials at three different harvesting times. You can see the higher flavonoid content, both for Sabrina farm and the Fortuna farm. Polyphenols, same curve, to science, same trend, antioxidant activity, same results. That means that nutraceuticals, while less easily detected by consumers, targeted marketing by the farmers, the cooperatives could give very good results. We briefly talked about industrial tomatoes. We worked in the area of Caserta, highest concentration of tomato crops. That's when we introduced the material. In that area, no mulching was used. This farmer, after 2 years, had already bought the machinery. He was so convinced about the effects of the system. We tested the system. You can see mulching material versus conventional method, and then of course they use digestate for manure, and the combination between the integrated manure practices and the new system led to higher marketable yields. We looked at the impact of the new system on the crop system. Instantly, so the increased production of over 100 tons. The most interesting parameters, which are the color of the fruit, the texture, soluble solids, were found to have improved considerably when mulching was used, and then in combination with reduced fertilizing and integration of the state. So, biodegradable pouches are mature materials or mature products that actually considered to the experience of a farmer who's been using this material for many years. Thank you. This is the end of my presentation. Yes, interview. I'm not wrong. Can we get the interview? Thank you for minutes, not more, because you're so focused up. Well, let me first of all thank you so much for the invitation to present our experience in the region of Campania. We grow vegetables, organic and biodynamic farming. So we have primary production and related activities so our products get to consumers' tables. We have catering section. So we have 200 hectares, 150 for vegetables on the field and 50 in the greenhouse. So our production is targeted for exports and foreign markets. 80% of our produce is sold on international markets, especially Germany and the UK and Switzerland as well. So we're based in Campania. We're specialized in the production of vegetable crops in the greenhouse, especially during the winter, starting mid-October till mid-May. We're specialized in vegetable leaves, leafed vegetables, and we have two processing plant, one for a different quality levels. This is you can see our greenhouse crops. As I said, we specialized in vegetable crops, and here we use mulching materials. We've known this material for over 15 years. We've used that for a long time, so we have some experience. We find no residues in the soil, and if any residues are there only for a few months on account of the thickness. So we use 0.12 to 0.15 micron, 3 to 5 months, depending on the production cycle of the crop we're targeting. You can see this is a ruler. More specifically, we use plantlets. We have a nursery, and then we plant them out on these textiles with holes, so we can irrigate from the top. This is end of cycle production of lettuce in the greenhouse. This is an example. Weed control is extremely satisfactory for us. This is one of our strengths. This photo was taken a few days ago. This is a greenhouse lettuce crop. Other advantages of biodegradable materials, better weed control, very good control of evaporation and transpiration. Thanks to the biodegradable fabric, we can better control evapotranspiration. And for a farm like ours, we need to take labor costs into account. So we have no costs to be taken into account to remove the plastic material that was used in the past. It's a major saving in terms of labor costs. Moreover, we have no disposal costs to take into account. There's much yet to be done, however, and I'd like to take this opportunity to encourage research in this area on the possible use of dripping wings on these fabric that would be biodegradable as well. We have a few weak points, as mentioned by some of the speakers during the session. So higher costs, which are nevertheless partially made up for by the better production. So we can, of course, receive some subsidies to biodegradable materials, and we can use this material for many crops, if not for all. Thank you very much for the invitation and for listening. Thank you very much for your interesting presentation, for this overview on this topic, greenhouse crops, especially. So I'll now give the floor to Alberto Poligo from Poligo Rota. As previously mentioned, one of the issues concerns the actual mulching process with direct planting. So it's an excellent combination because it actually enables farmers to perform different operations at a time. So Alberto, you have the floor for your presentation.
Hello, good evening, everybody, and thanks for the invitation. I will try and share my screen now. My name is Alberto Furigo from Furigo Rota, Italy. Ours is a family-owned company working the soil. We have specific seeding machines to seed biodegradable mulch textiles. Two systems are available. One is called Modular, and the more recent one is called Modular Jet. The first version makes it possible to plant through the mulching fields which have been already applied onto the soil. This simply seeds, while the modular jet system is a system which makes it possible to apply the mulch plant and the same fertilizers, drip lines, or whatever. Let's consider the details. 1% is one new available on the market, which has great flexibility concerning the distances. It's got an electronic synchronous mechanism whereby the operator can eliminate the borders so that you can vary the seeding distances in the row. The system is 100% electric, very flexible. The secret of our seeding machine is the synchronicity between the borders, the boring elements for the soil and the mulch, and the dispenser, which is these borders. The same machine can have a minimum number of borders, two, for example, as you can see to the right, for a distance of 120 180 centimeters. And if you add more borders, you can actually increase the number of borders, reduce the seeding distances, the planting distances down to 16 centimeters. The machine comes with two distributors, a mechanical and a pneumatic one. Usually the pneumatic one is used for catching seeds like bean seeds or courgettes, while the mechanical distributor is usually used for a couple of seeds in the same borders. In the same hole. Popular is named from the fact that it is need for wire transmission makes the assembly of the machine easier. In the front chassis, you can apply a seeding unit to seed a row of, for example, watermelon, pumpkin, or coconuts. I'm mentioning some. Then, if you add other units in a modular way, you can cover a broader number of another very important feature is that the machine has this system for depth control. Well, it sounds simple, but it's the only machine that allows you to control the planting depth. Through this system, you can see where it is recommended or needed. Here are your pictures because I don't know how the video works. As you can see, the machine is working. The system is quite simple. Front part there is a chassis which is coupled to the tractor to an electric company. Works. Then you see in the stereo seating, which is proportional to the speed or warnings on mulching fields that have been previously. You see a machine with multiple seating units. This is a 4-unit machine. Um, to your right, you have a machine for tests on other plants. This is the video. Well, I hope you could get an idea of how the machine works. You can visit website www.forigo.id. If you search Forigo Modular on the search engine, you immediately find our page with all the information. And now, the latest development by Forigo Modular. It mulching seeding machine, 100% electric. It's got unique features. This is a biodegradable mulching. Here we have an exclusive system for applying the textile in an appropriate way without creating any friction, without putting tension, excessive tension or stress on the textile. Then holes are made depending on the type of crop. Let's see the features. As I said, sorry, we only have a couple of minutes left. Otherwise we can't finish on time. Yes, in the front part, you have a roller for rolling the soil, and then you have a planting element where you basically plant as usual on the nude soil. Then complete covering with biodegradable mulch. And as last step, there is an electric knife which is synchronized with the seeds. Therefore, the mulch is exactly at the point where the seed is dropped. Through the display in the control, the operator had to decide where to seed them. We were even able to plant at a distance of 7 centimeters. We have to perforate the mulch. You go step by step, centimeter by centimeter, up to 1 meter. Through the display, you can also select the length or the size of the cut. You can cut very small holes, but also larger holes if created. Two types are available. One for cereal planting. You have pumpkin and other seeds up to 2 meters diameter. We have the single coil machine where 7 planting units can be installed. Dual coil machine. I've added some shades here as well. The two-coil machine makes it possible to plant for rows in this case it is one. Below one machine for inches. On the left you see a double line and other images for zucchini. The previous one was for radicchio. I'll go quickly through this. Let me remind you that we also have a complete range of machines for applying mulching textiles. As we said before, it's not easy to do so. Be dry heavily. You shouldn't undergo stress. Some pictures of the fruits planting. This is a test for no biodegradable mulching. I won't go into the details, into the agronomic details because I'm not an agronomist, but I think the results speak for themselves. Look at the root system development. If you compare mulching or yogurt and more tests of crops, look at the difference in the development. If you compare mulching and mulching. In radicchio, as we said before, these tests were carried out this year. Lettuce, major results were obtained thanks to the fact that the textiles held well with good production and no weeds. Melon, exceptional industrial tomato. That's it. Well, if you need some extra information, you can visit our website. Thank you very much, Alberto. Well, I think This is a very important part. That's why I let it. It's always been the subject of discussion between farmers, technicians, and operators. Actually, your machine has many people agree on the use of nitrogen. Some people believe that if you apply the with inadequate machines, you might come across problems. Yours was really the right solution. New technologies can well work. And nowadays we have specific funds for these new technologies. I think we have some time for a question now. Does anyone have a question? If so, we have time just for one question. Go to number 5. We've got 5 minutes left. Maybe the speakers may have questions themselves. You know, as Mr. Corelli was saying before, the larger, the higher number of flowers shows that the plant develops better with better results. And so they are superior to the conventional textiles. There is one question I have. The cost is higher when you buy the textile. Then, they are at 12 microns, not so 40 like the plastic films. I don't think we should consider the cost the way, but it's actually the development on the field that counts. I'm also surprised to see the machines, the seeding machine. Some farmers in some crops, in summer, resort to the practice of seeding, even on large surfaces, because they start in summer with higher thermal strength. You can obtain better food. Having a machine that allows you to plant within shorter period of time is certainly a great opportunity in favor of these textiles. These are just some comments. Sharon, would you like to add something? Should unmute yourself. All the experience gained over the years with biodegradable textiles has increasing a lot of farmers. Those using biodegradable plastics have decided that an even higher cost is no longer a cost. You can get a return on this cost. Today, we have lots of field experiences, and I believe that this is going to be the future if we are heading towards an increase in delivery. This will be the final result. We're all committed towards developing these new techniques, which can yield major results, especially on the health and wholesomeness of the crops. We need to consider what the end users want. In some cases, we see the bad results of wrong used in. So I think the future is here. So we both economic and environmental benefits. Well, some of you are asking how to get the training on our website www.chimicaVerde.it. You can find the form. It's downloadable. You can also ask questions to our email info@chimicaverde.it. I'd like to thank all the speakers, and I hope you all enjoyed the meeting.